Let's start with questions from homeworks. Does anyone have questions from homework? Nick? Worksheet or problems? Okay. All right. So, looking at number 15, first thing I'm going to do is decide what situation I'm in. This is side, 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 right? Because I'm just given 3 side lengths. So let's go ahead and draw us a picture then. Before I get going too far, I need to check if there's a triangle possible. Stop talking, please. To do that, I need to make sure leg plus leg is greater than the hypotenuse. It is. So I know there's one triangle here possible. Now the important question is, which angle do I have to solve for first? Nope. Biggest. When there's 3 angles, we have to find the biggest one first, so we're going to be solving for angle C. So when there's 3 angles to solve for, we find the biggest one first.
Wait, you said yesterday, 2 days ago.
If there's 2 angles to solve for, you find the smallest first. Yeah, that you're just getting confused between the 2 situations. That's okay. But that's the rule. If you have 3 angles remaining to solve for, we need to find the. Let's do it this way. Yeah. Okay, so we're going to solve for angle C here. I'm going to do it symbolically first and then plug the numbers in afterwards, because I tend to find that students make less mistakes when you're doing it this way than if you put the numbers in. So we're going to start by subtracting over the a squared and the b squared. And then we're going to divide over the minus 2ab. And then we're going to do cosine inverse of both sides. And that's my angle C by itself. So at this point, I'm going to now plug the numbers back in for myself. And go to my calculator. Now, super important on your calculator here, do this all in one line. Make sure you're using the fraction command. Don't try to chunk this up. You're going to mess up the order of operations at some point on your calculator. Just type it in the way it looks like on our sheet of paper, and everything should go pretty good. Be careful not to forget your negative sign when you divide over the minus 2ab. Oops. So I get 94.94. Well, that's fun. So now that I have 2 angles remaining, which angle do I solve for? The smaller of the 2. So if I go to my picture, which one is smaller, A or B? It's definitely A because it's opposite the smaller side, right? So I'm going to use a... Oh, did I put them in the wrong place? Oh, okay. So I'm going to use a law of sines here with my new angle C. I'm now going to cross multiply, divide, and then do sine inverse. All in one step. Is everybody okay with me just kind of shortcutting through some of that stuff? I think we were doing that at the end of last lesson. I got to that point, right? So there I get 36.71. How am I going to find the last angle? Yeah, good job. 180 minus angle C minus angle A. Oops. So 48.35. Feel good, Nick? Kate.
Was angle A the smallest or the second smallest?
It is the smallest.
Okay. So you go biggest, smallest.
Well, you're going to say smaller of the two, right? Because, right, I always say smaller of the two because in an SAS situation, it might not be the smallest. The given angle might be smaller still. You know, so I always just say smaller of the two, right? Because I want to just make it the same verbiage for all of them. And yes, in this case, it is the smallest. If we did the biggest one first, we know this is the smallest. But in SAS case, it might not be the smallest. The given might be the smallest.
Okay.
So I would just say the smaller of the two.
Yeah.
Does that make sense? All right. Let's start 7.2 here. So just as a recap, what we've been working on is solving non-right triangles, right? We've seen there's we've looked at 4 situations. We've done angle, angle, side, and angle, side, angle. Those we just use law of sines, where there's always one triangle possible. We don't have to be careful about the order in which we solve anything. It's just, those ones are straightforward. Nothing tricky. The other 2 we looked at was the side, 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 and the side, angle, side. For those, we need to use law of cosines first. For the side, 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 we have to check if a triangle is possible. So again, the way we do that is the sum of the 2 legs has to be greater than the hypotenuse. And then for both of these, when we have solving for 3 angles, well, let's just say with 3 angles remaining, we need to find the biggest angle first. And then with 2 angles remaining, we need to find the smallest angle. So that's the way that I remember it. Does that feel okay for everybody? Okay, so just kind of consolidating that. Notice that we've covered 4 situations. We talked about 5 possibilities. The remaining situation we haven't talked about is the SSA case. If you think back to your geometry class, if you remember, these 4, angle, side, angle, 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 side, 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 and side, angle, side, are all congruence theorems for triangles. That's why you're guaranteed just one triangle possible for these. The SSA was not a triangle congruence theorem in your geometry class. As a result, some weird stuff can happen. So that's what we're going to be talking about the whole of today, is this SSA case. So in the SSA case, we can have 0, 1, or 2 triangles possible. Our first step is going to be figuring out what's going on, whether we have 0, 1, or 2 triangles. Okay. The way we're going to do that is we're going to begin by looking at the given angle. So if the given angle is greater than or equal to 90 degrees, and if the side opposite the given angle is smaller or equal to the other given side, then 0 triangles are possible. So let's think about why that has to be 0 triangles, right? So if we have the given angle is greater than or equal to 90 degrees, what does that say about that angle? An angle in a triangle is greater than or equal to 90 degrees. What can we say about that angle? Okay, and how many right angles or obtuse angles can a triangle have? Just one. That means it's also the biggest angle in our triangle. So what does the side opposite the biggest angle have to be? The biggest side. So if it's not the biggest side, then we can't make a triangle out of it. That's what this is saying. So I'm just going to write then otherwise we get one triangle. So if the side opposite the given angle is bigger than the other side, then there's just one triangle. It proceeds as normal. It's no big deal. Is everybody okay with that idea? All right. Case 2. Oops. So the given angle is less than 90 degrees. Check that. So if that side opposite the given angle is bigger or equal to the other given side, then we just get one triangle. Otherwise, we can have 0, 1, or 2 triangles. It is not clear just from looking at the given information which situation we have. In the business, we refer to this as the ambiguous case, because just looking at the values of the given numbers is not enough to tell us whether we have 0, 1, or 2 triangles. So let's look at what we do with the ambiguous case then. How can we tell what's happening there? Because that's the one where it's unclear what's going to happen. Sound good? Let's look at an example. I'm going to do a specific numeric example and then to walk us through how we do this. So let's say we have angle P is 56 degrees, side P is 16, and side Q is 19. So I'm going to start the same way. I'm going to draw and label a picture. So P, Q, R, P, Q, R. I'm going to draw in the measurements that I'm given. Now, if I look at this picture, I notice this is SSA. Angle P is acute, less than 90 degrees, and side P is less than side Q. That's the ambiguous case, right? We have an acute angle, or SSA case. Our angle that we're given is acute, and the side opposite the acute angle is the smaller side of the two givens, anyways. That's what we need to, that's the conditions for that ambiguous case. Is everybody clear as to there's 3 things we need to check through before we can conclude that it's in this worst case scenario. All right. To determine what's going on, I want to look at the sine of angle Q. So I'm going to start up a regular old law of sines. So I'm going to do sine P, sine of angle P over side P, equals, and then I'm going to do sine of angle Q over side Q. And I'm going to get the sine of angle Q by itself by cross multiplying and dividing. I'm not solving for angle Q here. I specifically want sine of angle Q. I'm now going to take my calculator and figure out what sine of angle Q is. I want the number, the decimal there, because that decimal is going to tell me what is going on. So I get 0.984. If that number is greater than 1, that's the no triangle situation. That number is equal to 1. That's the one triangle situation. That number is less than 1. That's the two triangle situation, which is what we have landed on in this example. Is everybody okay to hear? Yes? Okay. All right. So let's finish solving this so I can show you how to find the two triangles, or the values for the two triangles. Whenever I have a two triangle situation, I'm going to divide my paper into 2 halves. So I'm going to do the work for triangle 1 in one area and the work for triangle 2 in the other area. In my experience, when students struggle with this sorts of problems, it is largely a part of we just weren't able to stay effectively organized. So in triangle 1 and triangle 2, all the given information is exactly the same. So I'm just going to call these angle P and side P and side Q all the same. But the things we're going to solve for, angle Q, angle R, and side R, I'm going to add a subscript to them denoting whether I'm working with the angle Q in triangle 1 or the angle Q in triangle 2. So I can really keep my work straight. Is everybody so far so good with how I'm setting this up? So I'm going to start in triangle 1, and I'm going to start where we left off before, where we have that sine of angle Q is equal to 19 sine 56 over 16. Was that right? Yeah. Or 0.984. How do we get rid of that sine in front of angle Q? We do sine inverse to both sides, right? So do sine inverse here and sine inverse over there. So Q1 is sine inverse of this 0.984. If I go to my calculator, that number is already right there. So I'm just going to do sine inverse of that previous answer. And I get 79.89. Is everybody okay so far? I'm now going to switch to triangle 2. Because now that I found my first angle in triangle 1, the corresponding angle in triangle 2 will always be the supplement of that angle from triangle 1. So what I'm saying then is angle Q2 is going to be 180 minus angle Q1. This is only true for the first angle you solve. So when I do that, I get 100.11. Is everybody okay to hear? I'm going to switch back to triangle 1 now. Notice in triangle 1, I know 2 of the 3 angles. To find the third angle, that's easy. I can just do 180 minus angle P minus angle Q1. Back to my calculator later, I do 180 minus 56 minus 79.89. So I get 44.11. I'm going to switch back to triangle 2. In triangle 2, I notice that, again, I have 2 of the 3 angles. Finding the third is then easy. Again, it's going to be 180 minus angle P, which is the same in both triangles, minus angle Q. But angle Q is different in triangle 1 and triangle 2. Make sure that you're using your angle Q from triangle 2 when solving for R2. This is why I try to divide my problem like in 2 separate sections like this, so I don't get confused as to which number goes where. That gives me about 2389. Still doing okay? All right. And then my last step, now I'm going to switch back to triangle 1 and solve for side R1. To do that, I'm going to use the law of sines. So I'm just going to use the sine 56 over 16. That's angle P over side P. And now I'm going to use sine of my new angle R1 over side R1. I'm going to cross multiply and divide. Now that I have that written out, I'm going to go to my calculator and type her in. 16 sine 44.11 divided by sine 56. So that gives me about 13.43. We'll do the same thing now in triangle 2. So I'm going to start with sine P over P. Notice that that is the same information in both triangles. But now I need to use angle R from triangle 2 over side R in triangle 2. Again, we'll cross multiply and divide. So there's that. So just grab the previous thing and update the 4411 to 2389. I get 7.82. Now, before I could declare myself finished, I'm going to check two things. First thing, I'm going to check to make sure that my angles add up to 180 in both triangles. They do. And then I want to check to make sure the biggest side is opposite the biggest angle, the smallest side opposite the smallest angle, the middle side opposite the middle angle for both triangles. That holds in both triangles. Is everybody okay there? To just kind of give you an idea of what's going on here, let's look at a little picture and I'll show you like how these two triangles are existing. Sound okay there? Oops. Actually, I do want that for a minute anyways. All right. So I have that 19 is one side, right? Oh, bugger. View. And then we want a 56-degree angle. Okay. So line. So that's my 56-degree angle. And I want to have a circle of radius 16. notice here that I have two separate intersections for that. Okay, now let's hide you. And actually, let's hide you. Oops. Yeah, hide you. Stupid labels on here. Okay. So now let's see. Give me distances for this. That's 19. That's 16. And there's my 7.82. There's my 100.11 angle. Oops. And there's my 2389. Everybody kind of see that? That's one triangle. And then if I did this one, and we look at this distance and this distance, there's my 16 and my 1343 side lengths, right? And I look at the angle measure, so this one, this one, this one, there's my 7989, and then this one, this one, this one, there's my 44.11. So there's how the two triangles are possible. You can see that it is possible to construct two triangles where we have 19 or 56, a 19, and then a 16. Right? I just showed you the two triangles. Just showing you that, like, yeah, that's how that works. I don't need to say that. All right. So for your homeworks, I want you to do in chapter 7, 5 through 10. The directions for 5 through 10 tell you just to determine if it's 0, 1, or 2 triangles. So like, you're just doing this part. You're not solving the triangle. You're just doing that much of it to determine whether it's 0, 1, or 2. Don't solve it. Everybody's okay?
Do not solve.
Do not solve it. You're doing too much. I mean, you can. It's not wrong to do it, but like, oh boy, you're going to waste a lot of time. Yeah. And then I'm going to ask you to do 11 through 14. The directions on 11 through 14 tell you that two triangles are possible. So you can skip that step and just go to the solving part. Okay? Does everybody make sense? Your test setup would be the same way. I would ask those as two separate kinds of questions. Like, hey, tell me the situation, like angle, side, angle. Tell me how many triangles are possible. don't do any solving. And then I would tell you to solve the triangle. And then I would tell you, no, this one there's 2 triangles, solve both of them. I would not mix a 2-triangle case into any other kind of problem. I would tell you in the directions that this one has 2 triangles. Everybody's okay? So that stuff 5 through 10 and 11 through 14 is due next Sunday. For this Sunday, I think we asked you to do 1 through 10, 23 through 26, worksheet 1 from chapter 6, and then chapter 7, 1 through 4, and then like 15 to, is it 22? Yeah. And that's due, well, let's make it Monday at midnight since we don't have school on Monday. Mr. Kulik won't be checking homework until he gets to school on Sunday or Tuesday morning. So, don't worry about it until Monday at midnight, I guess. Take an extra day. Okay. As an aside, in chapter 7, we have one more day for a lesson. We're going to have a review day, and then it'll be the test. So the test will be in the 2 class days from now, or 3, however you want to count it. You get what I'm saying, though. It'll be the week after next, since there's only 2 class days next week, because there's only 4 days of school. But just giving you a heads up that that's coming down the pike pretty quick. Okay, if you haven't gotten into chapter 7 yet, you'll want to get through some chapter 7 stuff this weekend so that you're coming in, you're ready to ask some questions about the chapter 7 stuff you don't understand before next week. You know what I'm saying? Okay. That's it for me. I'm going to stop here. You guys have, what do we got, like 8 minutes left or something?